I'm going to be solving this question in two ways. So let's start with the first method. A car valued at $600,000 depreciates by 10% each year. What will be the value of the car at the end of 2 years? So I can start by saying, okay, the first year, remember there was a 10% depreciation. Originally, it was 100%, okay, of $600,000. But now there was a 10% depreciation. So you have to subtract 10 from 100%, and that gives you 90%. 90%, which is also 90 over 100. And when you simplify this, you multiply 9 by $60,000, you're going to have $540. Now this is the value after the first year. Let's go get the value after the second year. For the second year, it's still going to be 90% because there was also a 10% depreciation. Times, how much was it after the first year? $540,000. And then 90%, that's 90 over 100. Again, when you simplify this, 9 times 54,000 will give you $486,000. So this is the value of the car at the end of 2 years. There's a compound interest formula, which is this. A is the amount, P is the principal or the initial deposit or initial amount. 1 is just a constant, R is the rate, and N here is the number of years. In this case, we have 2 years. But for depreciation, I won't be using plus here. I'm going to change this to minus. Now take note, you can only use this formula if the rate of depreciation is constant for each year, if it is consistent. If the first year the rate of depreciation was 5%, the second year it was 10%, you cannot use this formula. It can only be used when the rate of depreciation for each year is consistent. So let's do this now. A is going to be the amount at the end of 2 years. P is the initial value here, so that's $600,000. Then 1 minus. R here is the rate of depreciation, that's 10, so 10 over 100. And here, number of years, 2 years. So when you simplify this, this is $600,000. Then 1 minus, this is 0.1 squared. And just to hasten things up, 1 minus 0.1 is going to be 0.9. So the final answer here becomes $486,000. Just as we got when we used the first method. Like and share this video. I'll see you in the next one.